So we've been talking about carbon footprint and energy use and how reducing both carbon footprint and your energy use can not only improve the environment, right, carbon going into the atmosphere, but also impacts our daily cost. So one of the biggest users of electricity, which is from a fossil fuel, is light. All the appliances that you plug into your home, we investigated in vampire energy, those of course all use electricity, but light is the biggest user of electricity. And what we want to do here is start to think about what should be considered as we choose the best, most efficient, most environmentally friendly light bulb. So typically you would go to the store and just pick the light bulb based on price off the shelf. But what we're going to dig into today is a little bit deeper than that, really thinking about, what other factors should I consider as I choose a light bulb. So looking at your light bulb lab, we're going to go through today part 1. Part 1 is just a little bit of background. Here's our directions. Many people are switching their old, outdated incandescent light bulbs with newer and more efficient LED light bulbs. However, LED light bulbs are more expensive when you buy them at the store. We want to find out if the extra cost of LED bulbs is worth the investment for our families and for our impact on CO2 and the Earth's climate. So there's 3 different light bulbs that we're going to see in this data table. Incandescent is kind of the traditional light bulb. So a lot of us have these around with kind of like the little twisty wire inside. CFL, again, these are pretty common. They are what I like to call the twisty light bulb. And then LED, they've changed a lot recently, but they do look a lot like the incandescent on the outside. But they usually have some sort of post in the middle with all these little dots. And those are the LEDs, the light emitting diodes. So they look a lot like the original incandescent, but they act differently. So we have some data here looking at lifespan of the bulb. So how long it can last if you just plugged it in and turned it on. How many hours would it stay lit? Watts is looking at how much energy it uses, and then cost per bulb is thinking about off the shelf from the store. So a few questions to investigate. Looking at electricity, those are the watts. Looking at which one lasts longest, that's of course the lifespan. So you can pause and fill those 2 in. Now we do have a calculation that we need to do here. We want to know how many total bulbs would we need if we're trying for 50,000 hours of light. So we can see here that no light bulb by itself lasts 50,000 hours. So if we wanted 15,000 of hours light, how many of each light bulb would we need? So we have to do a short calculation. For example, LED, we need 50,000 hours, but each light bulb only lasts 10,000. So by dividing those together, we figure out pretty quickly that we would need 5 total LED bulbs. So you can again pause and do the same calculation for both CFL and incandescent. If we need 50,000 hours divided by how many hours the light bulb actually lasts. Number 4, which light bulb is the most expensive at the store? So again, looking at the prices there, which one costs the most off the shelf? Can say what light bulb it is and put the cost in. Then we have a couple predicts. Predict what factors would need to be considered when determining the best long-term bulb. So like we said in the beginning, typically we only think about this last factor, cost off the shelf. But what other things might we want to consider if we're choosing the best long-term light bulb? It can be something from this data table or something you're thinking of separately. Number 6, predict which light bulb of the 3 are going to be most cost effective for that long-term 50,000 hours. So kind of thinking about what you recorded in number 5, choose a light bulb and say why that one is going to be the best overall. Number 7, you're going to use this video. If you click here, just to get a little visual, both how they look, also temperature and energy use for each of the light bulbs. So when you hit play, you'll see myself and Mr. Graybo showing you the lights. Try to get at least 2 observations for each light bulb. And then the last thing we need you to do to finish up part 1 is go through, count the number of light bulbs in your house. So start kind of at your front door, look to the left, look to the right, count lights that are in the ceiling, count lights in lamps, and just get as close of a number as you can to number of light bulbs at home. We're going to need this number a little bit later in the activity.